Hello and welcome to your video lesson on rational numbers. So this is a great lesson for you to think about all the numbers that you see and what is connected about them. So get your thinking caps on, come ready thinking about what do you already know, and let's do our best because that's what matters. So our learning objective today is that you are able to express rational numbers as decimals and decimals as fractions. So first of all, the thing we need to know is that rational numbers, that vocab word and that word you're going to hear and see and use a lot, rational numbers are really just numbers that can be written as fractions. And so when you think about that, most numbers can be written as fractions. So here in this chart, you see that this encompasses everything. Rational numbers, you see a fraction, you see a repeating decimal, you see negative numbers, integers, you see whole numbers. So all of those things are rational numbers. And we know whole numbers can be written as fractions. For example, 8 over 2 is the same as 4. I know that integers can be written as fractions. Negative 6 over 1 is the same as negative 6. I know that 3/10 is the same as 3/10. Percents are also rational numbers. For example, 26% means 26 per 100. So rational numbers is any number that can be written as a fraction. So it's a lot of them. So any fraction, positive or negative, can be expressed as a decimal. So we can write fractions as decimal, and you can do that if you divide the numerator by the denominator. That's also true if you'll see at the bottom, you can also do it if you get the denominator to be 10, 100, or, well, that should say 1,000, golly gee. 1,000, change that, and then you read it using that place value. So we'll practice both ways. And the nice thing about math is that you pick the strategy that works for you. So here let's practice writing a fraction as a decimal. If I have 5/8 and I want to write that as a decimal, 5/8 means 5 divided by 8. It also means 5 out of 8. So there's different ways that you can read that. So if I do that, and I could do 5 divided by 8, really important that you remember that numerator divided by denominator as a fraction, it's like this. That also means numerator, no dogs in the house, I like to say. That first number goes inside. So I was going to divide this. I know it's going to be less than 1 because 8 can't go into 5, but 8 goes into 50, 6 times for 48, with 2 left over. 8 goes into 20, 2 times for 16, with 4 left over. And 8 goes into 40, 5 times with none left over. When I get that remainder of 0, I know my decimal stops. So 5/8 is the same as 625 thousandths. So notice I can read that as a thousandths. You might also know that 5/8 could be written out of 1,000 if you multiply by 125 on both the top and bottom. You'd still get that. And if I read that, I read it like this as a decimal. So that's the other strategy that I'm going to show you. It's the one I prefer, but not all numbers are factors of 10, 100, or 1,000. So you can't always do it. So dividing is a good option then. So again, you want to make sure that you understand this part. I can write a fraction or mixed number as a decimal either by dividing or by writing it as an equivalent fraction with a denominator and then reading using place value. So this might be a good time. If you feel good, you can try and come back or watch and go from there. So 3/4. I can do 3 divided by 4, and 4 goes into 37 times for 28, 2 left over. 4 goes into 25 times, none left over. So this is the same as 75 hundredths. I could also see that. I know a second way. I'm not always going to show you both ways. You decide what works for you. If I make this out of 100, because 4 is a factor of 100, I just have to multiply by 25 to make an equivalent fraction, which would give me 75 over 100, or 75 hundredths, reading in your place value. When you have a negative, you just know that equivalent, your answer would be negative, and you treat it as normal. So again, I know that this is a negative over a positive. I know my answer is going to be negative. And I could do, again, I could do 3 divided by 5, use my decimals, or I have negative 3 over 5, and equivalent to that, if I want to get this to be 10, would be multiplying that by a 2. Negative 3 times 2 is negative 6. I read this as negative 6/10. So 2 options. Last one here, we know that our 4 is my whole number, and we read a decimal as end. So another way to read this is 4 and 13/25. Okay, so again, I can do division and just keep that 4 as my decimal, so it'd be 4 and something. I could do 13 divided by 25, do my division, or again, I see that my denominator is a factor of 100, so that's a place value. If I multiply this by 4, I get, hey, there's 13 cards in a suit, in a deck of cards. There are 4 suits. There are 52 cards in a deck. I read this as 52/100ths. So 4 and 52/100ths is equivalent. There's quite a little bit more to this video, but I'm hoping this is ringing in a bell. The only difference from what you did last year is that there are negatives now. So every rational number can be written as a terminating or repeating decimal. And so a decimal, like the one we saw, is called a terminating decimal because the division ends. Okay, it ends or it terminates with a remainder of 0. You will see things that don't do that. So, for example, if the division does not end, a pattern of digits is called a repeating decimal. And these have a pattern, and you can use bar notation to show that, and that should also be familiar to you. Some of them are helpful to remember, so another way to write this is 3/10 repeating with that bar notation. This one would be negative 28/100ths repeating over both digits that repeat, whereas this one's 60 and 715 thousandths with the 15th repeating. You're going to write it, you're only going to put the bar notation over the digits that repeat. The 7 doesn't repeat, so the bar notation goes over that. All right, let's write a repeating decimal. So again, we know that the whole number is separate from the decimal part. Whole numbers go in the ones place and on, whereas the decimal goes in the smaller ones to the right. So here's what you have to do is you can leave that there, and then you're doing 2 divided by 3. If you need a placeholder, you can leave that there. Put my decimal in. 3 doesn't go into 2, but it goes into 20. 6 times for 18, 2 left over, 6 times, 2 left over. You're going to keep seeing that pattern. If you keep getting that same remainder, this 6 goes on. So I know that I can write 6 repeating. Sometimes if it asks you to round, I might be saying, I'd look to the place and then round, and then you do like an approximately, say this asked me to round to the 100ths place, it would look like that. All right, so see if you can try these, writing these fractions as a decimal. These are going to be repeating decimals, so you're going to practice that bar notation. So since none of these denominators can go to 10, 100, or 1,000, I know my strategy is going to be to do division. 7 divided by 12. 12 doesn't go into 7, but it goes into 70 5 times for 60. That's 10 left over. Bringing down an additional 0. 12 goes into 100 8 times for 96. There are 4 left over. 12 goes into 40 3 times for 36. 4 left over. I'm going to keep getting that 4 remaining, and I'm going to keep saying it goes in there 3 times. So that 3 is repeating. So I can write 7/12 is the same as 5, 8, 3. Bar notation only over the 3. Next one, you can see it's a negative, so I know my answer is going to be negative. I'm just going to do 2 divided by 9. 9 can't go into 2, but it goes into 20 twice for 18, remainder 2. Goes into 20 twice for 18, remainder 2. You'll catch on pretty quickly if there's a pattern. So this would be 2/10 repeating with that bar notation, negative 2/10 repeating. Moving on, then we have 3 and 1/11. So again, I know that 3 is constant, 3 and 1/11. I just need to do 1 divided by 11. 11 doesn't go into 1. Again, I know my 3 is there, so if you are going to forget, just put the 3 there because you know the whole number. But 11 doesn't go into tens. There's a 0 in the tens place. And then I add in a 0 where I need to. 11 goes into 100 9 times for 99 with 1 left over. Bring down a 0. 11 doesn't go into tens. You do have to put that 0 in that place. Bring down another one. 11 does go into 100 9 times. And you're going to see that pattern continue with 2 digits now. So this would be 3 and 9/100ths, both of those digits repeating. I think you're doing great. I hope that you are engaging and rewinding if you need to, pausing when you need to, writing things down. All right, real world, where do we see fractions, decimals? Everywhere. Baseball, my big fans, you have a lot of stats in baseball. So in a recent season, the New York Yankees shortstop Derek Jeter had 6 hits in 22 at-bats. Round to the nearest thousandths, should have S at the end, find his batting average. So again, a big place we use decimals in the real world. First thing you want to do is figure out his batting average by dividing what he had, the number of hits, 6, compared to how many times was he at bat, 22. So that's a division question. Remember, you set that up using 6 divided by 22. So we know it's going to be less than 1 whole. 1 whole would be he had 22 out of 22. So when I do that, I get a decimal. It's going to actually be 0.2727 with repeating. But since they want me to round to the thousandths, I would look to the 10 thousandths. That's 5 or more, so I'd raise the score. Batting average is about 273 thousandths. That's not very good at that point, but could get better. So what we know is that rounding up piece right there we just did. I guess I did the work up here, so that fits there. So kind of step by step, do your best, take your time. We're almost there, friends. You are doing great. Terminating and repeating decimals are also rational numbers. Let's keep using that language because they can be written as fractions. So both types can be written as fractions. Repeating's a little trickier, but you'll practice. So let's practice writing these as fractions. My favorite thing is that you simply write it how you read it and then simplify. So for example, I read this decimal, not 0.45, but I read it as 45 hundredths. So because it's 45 hundredths, I can write it as 45 out of 100, like here, and I can read that again as 45 hundredths. So 45 is 45 hundredths, you could write it as, or you could read it as 45 out of 100. So for a decimal, just write it as you read and then simplify if necessary. So for example, I have 45 out of 100. I'm actually going to change this. Remember that common factor, so I know they share a factor of 5. So I reduce that by 5. 5 goes into 45 9 times. It goes into 100 20 times. So 45 hundredths is the same as 9 20ths. Try these next couple. Notice we're writing them in simplest form. Fraction or mixed number. So I have negative 14 hundredths. So I know it's a negative 14 in the hundredths place, like that. So then I know they're both even. They share a factor of 2. So this is the same as negative 7 50ths. Next one, 8 and 75 hundredths. So I can write it as 8 and 75 hundredths. I know that 75 and 100, I could, they share a factor. I'm going to reduce the simplest form of 25. So this is 8 and 3/4. Negative 3 and 15 hundredths. Negative 3 and 15 hundredths. Just read it and then write it in the opposite form. These are the easiest for me because I can read and write what I'm saying. Here they share a factor of 5. So this is negative 3 and 3/20. I think. Correct me if I'm wrong. Last one, we have 32 hundredths. 32 hundredths. They're both even. So I could start with 2, but I also know that they share a factor of 4. And 4 goes into 32 8 times. 4 goes into 125 times. So 32 hundredths is 8/25. Okay, last little bit here. There's a little trick for repeating decimals as fractions. If it's right next to the decimal, if it's in the whole number spot, we know that there are 10 digits that could fit here, 0 through 9. So anytime you see this, you actually just put that number over 90 over the digits, over 99. So then this actually can be simplified also. They share a factor of 3 or of 9. So this is the same as 3 divided by 3/11ths if you write that as a decimal. Same thing over here. So we have a -1, and then we have 1 digit there. So that could be 4 out of the 9 digits that could go there, and that's already reduced. It's a little trick with those repeating ones if it's right next to the decimal. Last one, see if you can try this using that word problem. How would I do NASCAR driver Jimmy Johnson won 6 out of 36 races, rounding to the thousandths, what fraction of his races did he win? So know that you're dividing. Find the fraction of races he wins, so that's a fraction would be 6 out of 36, which is the same as 1 out of 6. So then you can change that to a decimal, bring that to class, and we'll check it. Have a great day. Have a great day, and review if you need to. Pause, rewind, go back, try some IXLs, check out somebody else's video if you want to. You're doing great.